sketching 3-plane. So we're going to sketch it in three-dimensional space here. Very first example, d equals 0. We're talking about xy planes. Essentially, this is how it works. When y is equal to 0, it's along the other two planes. So we should be having a plane that is on the xy plane itself. The xy plane means it's every combination of x and y possible. So as you can see, this plane has height and depth, which means it goes z is our height and x is our depth. So that is when our y is equal to 0. When z is equal to 0, that means we're on the other two axes planes. In other words, that's the x and y axis. The x and y axis have depth again, but along the y-axis, and a distance left and right on the x-axis. So this is our x, this is our y. That's when z is equal to 0. And finally, I drew it somewhere. Here it is. When y is equal to 0, we're on the xy plane, which means we have height. Yeah, this one. Yeah, we have too many y equals 0s. Thank you. That should be x equals 0. YZ plane. That's this one here. Good. Okay. For some reason I didn't have all three written. XY plane. When x is equal to 0, we're on the height, which gives us our z. And we have left and right width, which gives us our y. That's when our x equals 0. That is the first case. Supposed to be the easiest. Okay. That is when we have two coefficients and d is equal to 0. If we have two coefficients equal to 0, but d is not equal to 0, we'll quickly jump and show you what that looks like on the next page. We're talking about ax plus by plus cz plus d equal to 0. So our second one was when d was not equal to 0. So it's some number. We'll say d is 5 in this case. And two of the variables are equal to 0. So for argument's sake, let's say a and c are equal to 0 in this one. When we go to plug that in, we're going to get 0x plus, we'll give b just a value of 1 to make it easy. So plus y, c is 0z, d is 5, is equal to 0. When we go to equate this, y plus 5 equals 0, y equals 5. Okay? Y equals 5 is very similar to our xy plane before. I'm going to get this right. We have our x, z, and y. Negative 5. Let's do it the other way. Let's say d is negative 5 because I made more room on the right. So that's positive 5 now. Okay? So what that means is recall when y was equal to 0, what plane were we on? XZ plane, right? We're on the opposite two axes plane. If you guys remember, that's where we drew our red plane. It looked roughly like this. It went across to this place here. Okay? We're talking about that plane. But that's when y was 0. When y is the number 5, so say this is where 5 is, we have the exact same plane. The only difference is it crosses where y is 5. It's parallel to the y equals 0 plane. So that means, I'm going to try to draw this parallel to it. We have a plane crossing through there. I'm going to draw it a little smaller. Parallel to the first plane, the only difference is this plane is cutting right at 5. Okay? So parallel to the original, only difference being is it's no longer where y equals 0. We actually have a value because d has a value. That same thing will happen with the other two. If we have x is equal to 0, sorry, let's say x was equal to 5, we would have something that is parallel to the zy plane. Okay? And remember our zy plane, that gave us something that was kind of flat like this, up and down. This was our y, this was our z. When x is 5, if say that was 5, we'd have the same kind of plane just cutting through the number 5 over here. it would be parallel to the original plane across there. Okay? And same with the horizontal type looking one. So after many tries, that's the idea of what's supposed to be the simplest when drawing in 3 space. Okay? Okay, case number 2 is when we have actually 2 variables. Still talking about our Cartesian form, ax plus by plus cz plus d equals 0. Okay? In this case, only one of these variables is equal to 0. So either it's a, b, or c. And in the first one of the case, we're going to go when d is also equal to 0. So let's make an example of that. Ax plus by plus cz plus d equals 0. Okay. So one of the coefficients is equal to 0. Let's say it's z, or c in this case. So z is equal to 0 and d is equal to 0. We'll give a and b values. A can be 1 and b can be the number 2 maybe. Okay? So when we plug these in, we get 1x plus 2y plus 0z plus 0 equals 0. When we simplify, x plus 2y equals 0. Okay? Now I want you guys to look at what we've said to do here. They've given you step by step. Find a point with missing variable set equal to 0. Okay? Set this point to 0, 0, 0 and draw a plane containing the missing variable access to this point. Seems very arbitrary. Let's draw our 3 space and connect the words to it. Okay. If we were to plug values in, so let's say we plugged in 0 for x and 0 for y. Okay? We would essentially get 0, 0, 0. Or let's say we just plugged in for one of them. And I'll show you what I mean by that. Let's say we get 0. So x is 0 plus 2y equals 0. So when x is 0, okay, we're trying to figure out what our y value is going to be. Well, it ends up being 2y equals 0. Y ends up being 0. Okay? So in other words, when x is 0, y is 0. So we're touching this origin here. And we don't have a value for our z, our up and down axis here, right? We have x, y, and z axis. So we know we're hitting the origin. Okay? And that's what they mean by joining this point to 0, 0. Find a point with missing variable set equal to 0. So we have and we're going to join this to 0, 0. So what we're going to do then is we need to find a point with this specific equation here. This is very important. It says that x plus 2y equals 0. We need to find values that will make this true. And there's going to be many, many values that will make this true. But the best way to do it is to just set the opposite coefficient. So what I mean by that is x plus 2y equals 0. Well, our a coefficient is 1. And our b coefficient is 2. Well, if I make x 2, okay, so if I make this 2, and I make y 1, we're going to be working with values that are the same. The only difference is I have to make it 0, so one of them will have to be negative in this case. So for instance, let's say we make it x negative. So in this case, x is equal to negative 2, opposite of its coefficient. Remember the b was 2. And y is equal to 1. When that's the case, negative 2 plus 2 equals 0. 0 equals 0. So we found a coordinate. We know that z is going to be 0. Doesn't exist. Our x is going to be negative 2. So we jump back to 1, 2. We're at negative 2. And our y is going to be 1. 1. So we're at a point right here. This point is negative 2, 1, and 0. Okay? What we do from there to draw this is we connect it to 0, 0. And then our plane works from there. So let's do this in a different color. It goes up and it cuts back down in the same angle. So this plane is on an angle. It's in between our two X and Z axes, you could say here. Sorry, X and Y axis. This is our X, this is our Y. This is touching the Z axis. It has an infinite amount of values of X, the X axis. It's going to actually, if I draw it straight, cut directly through it, okay, right at the axis, and it's going to end up somewhere in between our Z and our Y axis. That's for the first case, okay? So we always join it to 0, 0. We then find two values that make our statement true, which was this statement here, and we found two values, -2 and 1. We connect a line from 0, 0 to that point, and we just draw up and across, and we have our plane, and it's going to slice right through the z-axis. So whatever variable is missing, it's going to slice directly through that variable when going through this. That would be A, with one coefficient and D equaling 0. When we have one coefficient and D does not equal 0, we find the two intercepts, draw a plane parallel, that's supposed to say to the missing variable axis. Okay? So let's talk about that. Case B, AX plus BY plus CZ plus D equals 0. Well, in this one we said one of the variables is 0. Right? We have two variables in this one, right? Yeah, two variables. So in this one, let's say that our Z variable is 0. Okay? Or sorry, our C. C will be 0. D is not equal to 0 in this example. Just give it a value. D equals 6. Okay? And then we'll give A and B some values. A and B can be 2 and 2. So we go to plug this in our Cartesian form. We have 2x plus 2y plus 0z plus 6 equals 0. Okay. So now we have 2x plus 2y plus 6 equals 0. We have two variables and a non-variable d. Okay. This is going to be a little different. So we jump back to our instructions again. Find the two intercepts and draw a plane parallel to the missing variable axis. So we need to find the two intercepts. And what they mean by that is we have an x and a y. We're going to find those two intercepts. We're going to find the x-intercept, and the x-intercept is when y is equal to 0, and we're going to find the y-intercept, and that's when x is equal to 0. We're going to plug it into this simplified equation we have here. Okay? So, let's do the first one, our x-intercept. When y is equal to 0, we get 2x plus 2 times 0 plus 6 equals 0. Okay? Well, that gives us 2x plus 6 equals 0. 2x equals -6. X equals -3. Okay? That's an important point. We'll hold on to it, then graph it. When we do the opposite, does anyone know what our y-intercept is going to be? It's going to be the same thing. Y equals -3 because it is the same value. If we put this equal to 0, we're just going to have 2y plus 6. 2y equals -6. Y equals -3. Okay, I just did that math quickly so we can get to the drawing part because that's important. So, let's draw our 3 space here. Okay, so we have our 3 space, we have our x-intercepts. Our x-intercept is at -3, so 1, 2, 3 on x. Okay, and your y-intercept is at -3 on the y, so that's actually back here. 1, 2, 3. Okay? So now what we have is we know the plane is going to cut those 2 points. What that means is we have a plane that's not going to touch our z-axis. So this plane, we'll do it in blue here, cuts through here and is parallel to our z-axis. Think of it like that. Okay? And that it does not touch the x-axis, but it does continue on cutting through those 2 major points. It goes on from here, and it goes up and down from here. But it cuts those 2 axes for us.
So it's like it's going behind the...
Yeah, it's going behind the z. Well, remember our old one cut right through the z. This is parallel to that. This red was our old one. So the old one kind of cut right through the z-axis. This is parallel to it. Okay? We've just pushed it out more because we have a d value. So remember, what ends up happening in our first 2 cases is we start with the basic one when d is equal to 0, where they're on a plane, okay? Or in this one, we're cutting through the z-axis. Then we work with when d is not equal to 0, we just have planes that are parallel to that. And they're in reference to their numbers. So I'll try to bring up the other one too. If you remember, oops. Oh, it's not going to work when we do it that way. Oh well. Let's go back to our single display. Okay? So we're just parallel to what we had before. Okay, finally the third one. Goodbye. We have 3 variables. Again, talking about the Cartesian play, a x plus b y plus c z plus d equals 0. Okay? None of the coefficients a, b, or c equals 0, but d equals 0. Let's think of an example. ax plus by plus cz plus d. D equals 0, and we find, let's say a is 1, b is 2, and c is 4. Okay? So we get x plus 2y plus 4z plus 0 equals 0, so we just drop it. X plus 2y plus 4z equals 0. Okay? So now what we're trying to do is we're trying to actually find coordinates along this. So determine 2 points in addition to 0, 0, 0. Okay, so 0, 0, 0. When D is 0, we're always going to cut through the origin. Okay? In our first example, it was a plane cutting through the origin. In our second example, it was a plane cutting through the origin, but then moved a little between 2 axes. And this one, we're not going to be on any of the planes specifically, but it's going to cut through exactly at 0, 0, 0, okay, on an angle. Now, we just got to find coordinates here. So what that means is we're going to plug numbers in for certain variables and see what we get for them. So, determine 2 points in addition to 0, 0, 0. We take a look. We have x plus 2y plus 4z. Well, one of the ways to go about this is to find out when it crosses certain planes. Okay? So what I mean by that is, let's say we're going through the z plane. What that means is, that's when x is 0 and y is 0. Okay? So we know our coordinate's going to be 0, 0, some value of z. We plug those into our above equation. So we would get 0 plus 0. Oh, geez, I plugged in a bad example. That's just going to give us z equals 0. We already know 0, 0 is an example. Okay, that was an example of something you could plug in. Let's go for the next one. When x was 1 and when y is 1. That would give us 1 plus 2 times 1 plus 4z equals 0. Okay? In that case, we're going to get 3 plus 4z equals 0. 4z equals negative 3. Z is equal to negative 3 over 4. So, one of the coordinates is 1, 1, negative 3 over 4. So we found 1 point. Another one we can do is when x is 2 and y is 2 if we like. So we get 2 plus 2 plus 4z is equal to 0. That's okay. So we're plugging in the values when x is 2 and y is 2, again solving for z. That's going to give us 2 plus 4 plus 4z equals 0. 4z equal, oh, that's the same thing. Oh, it's because I did a scalar multiple. I apologize. Having trouble today. Let's do 3. Gives us 6. 8 plus 4 is 0. That's a better example. Z equals a half. So we have a point of 2, 3, and a half. Here's our second point. So these points are important when we go to set up our 3 space here. We have our 3 space. Remember, one of the points is 0, 0, 0, which is exactly what we found to start. Another point is going to be at x at 1. So here, let's say it's 1. Y at 1. Okay, so if we draw our box. And then negative 3/4. So down here. So our point's going to join here. And our other point is going to be x at 2, y at 3, z at a half. So it's up a bit. We're going over like that. And then we connect those 2 points. Okay? So that is essentially our plane right here. It looks like a triangle. Conceptually, a much harder idea, but when drawing it in this process, a lot easier. We essentially only have to draw a triangle, which is very similar to when we were drawing our vectors before. We're starting at the origin. We're just coming up with 2 points along there. And then we're connecting the dots. Okay? We've got that. And our last example there would be when d is not equal to 0 and none of the coefficients are equal to 0. How do we go about drawing it? The idea is similar. Let's give ourselves some values again. We have ax plus by plus cz plus d equals 0. We're going to give them different values. A will be 2, B will be 3, C will be 4, and D will be 12, to make it easy. Is equal to 0, okay? In this case, you have all of these numbers in Cartesian form. You're going to find all of the intercepts, okay? If you jump back up to the instructions, none of the coefficients A, B, C are 0, and D is not equal. Find the 3 intercepts and draw a plane through these points. So, in other words, we're going to find when our z-intercept, when we have x is 0, y is 0, we're looking for z. Y-intercept, when z is 0 and x are 0. And our x-intercept, when y and z are both 0. Okay? We look for all 3 by plugging 0 in for the numbers. So our z-intercept, that's when x is 0 and y is 0. For z plus 12 equals 0. That gives us 4z equals negative 12. Z is equal to negative 3. So that's one of them. Z is negative 3 here. And the next one, obviously it's going to cancel out the other 2 when it's 0. So in this case, we're only going to have a 3y is plus 12 equals 0 when we plug in those zeros. Y will equal negative 4. And on our last example, we're going to get 2x plus 12 equals 0. X equals negative 6. Okay. So these 3 points, 0, 0, negative 3, 0, negative 4, and 0. And negative 6, 0, and 0. We draw those 3 points in 3 space and connect the dots. Our first point, 0, 0, negative 3. Okay, so here's our first point here along the x-axis. Our second point is 0, negative 4. So we'll say that's negative 3. This is negative 4. That's our second point. And our third point, x at negative 6. We connect the dots, and this is our third plane. Conceptually, again, a difficult idea. Okay? Because of the angle we're looking at, it ends up looking like a triangle. Conceptually a hard idea, but algebraically easier to do. We just plug in zeros, find 3 points, 3 x-intercepts, and connect the dots.